I'm going to go over exercise 102, question 2c as requested. So I need to find two square roots of that complex number, which is 21 minus 20i. So the first thing I'm going to say is I'll let that be equal to x plus iy squared, so I can equate the real and the imaginary parts. So now 21 minus 20i equals, I know that this is going to turn into x squared plus 2xyi minus y squared. I know that that's going to turn from plus iy squared into minus y squared because I squared is -1. Okay, so now I can equate real and imaginary parts, and I can say that 21 is in fact equal to the real parts, which is x squared minus y squared. And this is how I like to do simultaneous equations, with some numbers like that. And then equation number 2 will be the imaginary component, which is minus 20, is going to be equal to the imaginary components, which is minus 22xy. And that'll be equation number 2, but I'm going to manipulate this one, so I won't call it equation number 2 yet, because I'm going to change this into y equals half of minus 20. So y equals minus 10 on x. Sorry, not half of minus 20. I'll take the 2 and the x over. Okay, so I have equation 1 and equation 2. There's a couple of ways you could do this one. It's probably easiest to use the substitution method and substitute equation 2 into equation 1. So I'm going to substitute 2 into 1. This is just how I show my working for simultaneous equations. So substituting, I'm going to get 21 equals x squared minus -10 on x all squared, and then I'll expand that. I'll get 21 equals x squared minus 100 minus 100 over x squared, and then I'll multiply that x squared out. So on the left hand side I'll have 21 x squared equals x to the 4 minus 100. Then I'll set it equal to 0 and see if I can factor it. So I'll have x to the 4 minus x to the 4 minus 21x squared. Is equal to 0. Okay, so I need to factor this and solve it for x. I can factor this using sum of b product of c. So I'm looking for two numbers with a sum of b, which is minus 21, and a product of minus 100. Start with some factors of -100. One of them has to be negative because both of these numbers, one of them has to be negative because when they multiply they have to get a negative number. So I'm thinking 21, 25 and 4, I think. Yeah, and if I make 25 negative and positive 4, I'll get -100, and minus 25 plus 4 will get me 21. Minus 25 plus 4. Okay, so they're my two numbers, minus 25 and 4. So I can factor this as x squared minus 25 x squared plus 4 is equal to 0. Okay, good. So now I know that x squared minus 25 is equal to 0, or x squared plus 4 is equal to 0. And of course I know that x exists within the real domain. Therefore, x squared plus 4 has no real solutions. You do need to state that. It's not a given that there's no solutions for x squared plus 4 equals 0. Of course, I can see it's going to equal x squared minus 4, and then I'm going to yield an imaginary or a complex solution. But we know that I've equated real parts here, so x has to be real, and therefore I make that statement where I say x exists within the real domain. That's what that statement says there, and therefore there's no solutions for that. So that means my only solutions lie within x squared minus 25 equals 0. So I have x squared minus 25 equals 0, x squared equals 25, x equals plus minus 5. Okay, they're my x values. I usually like to highlight, and then I'll highlight my y values, but I'm still going to write a concluding statement saying therefore x equals this and y equals this. So I'll substitute both of those into equation 1 or 2, whichever one's easiest. Equation 2 is probably simple. So I'll substitute x equals plus minus 5 into equation 2. Equation 2 was y equals minus 10 on x. So I'm going to have y equals minus 10 on 5, or y equals minus 10 on negative 5, and therefore y equals negative 2, or y equals 2. So they're my two solutions, and I need to write a summary with those. So I'm going to say when x equals 5, y equals negative 2, or when x equals negative 5, y equals positive 2. Wording's important here, because I'm saying that this solution here is a distinctly different solution to this one. There's two solutions. There's not one solution where x equals 5 minus 2, negative 5, or 2. I'm saying when x is 5, y is negative 2, or when x is minus 5, y is equal to 2. So they're my two solutions. To answer the actual question of what is the root, I'm going to say the root of 21 minus 20i is equal to, well, it's that first one, which is going to be 5 minus 2i, or minus 5 plus 2i. And you might see that written as, I'm just going to write it in a different color, you might see that written as plus minus 5 minus 2i, because the 5 and minus 2i can both change signs there for both solutions. So that's my final answer. I equated the real parts, and then I used the substitution method to solve for x, and I ended up with two solutions. And I had to establish that at that point there, only one of the solutions was valid, because when I equate real parts of a complex number, I'm stating that x cannot take on imaginary values. Therefore, x squared plus 4 equals 0 is not valid. Then I can continue on and substitute x is plus or minus 5 into either equation, and I chose equation 2 because it's simpler, that there's no reason you couldn't use equation 1, to get my two corresponding y values respectively, and they're both different.